Hello everyone, welcome to this session where we will dive into solving this classic projectile motion problem from the October 2019 paper AS Physics Unit 1. Well, I'm calling this question a classic one because we don't see these types of questions often in the recent papers at least. So there might be a good chance that a question like this might pop up in your exams, the upcoming ones. So let's see what the question has to offer. The photograph shows an area of land where the golfers can practice their golf shots. So this question is talking about golf shots. You know what a golf shot might look like. It's a projectile, of course. The distances are marked out along the land in front of where the golfer stands to measure the distance traveled by the ball. Distance traveled by the ball is the main thing that the golfer wants to measure here, which is basically, if you think about it, this is just the horizontal displacement, SH. All right. Two levels are available. If the lower level is used, the ball lands at the same height from which it was hit from. This means that once the ball lands on the ground, it will again return to the same height, which means that same height it was hit from. This means that the vertical displacement, once it hits the ground, will be 0 for the lower level. Okay, then we have another level, the higher level. If the higher level is used, this enables the ball to be hit further. So the ball will be hit further if the higher level is used. And by this, they mean that the horizontal displacement will be greater as h will be greater for the higher level. Okay, this is what they mean here. SH will be greater for the higher level. Okay, now let's get to the technical details. Above is given an initial velocity of 33 meters per second. Initial velocity 33. The angle to the horizontal is 28. Okay, usual projectile stuff. When hit from the lower level, this ball travels the horizontal distance of 92 meters before landing. Here we have the horizontal displacement. Again, for the lower level, 92 meters. Okay, before landing. Use of the higher level increases the horizontal distance traveled before landing by 10 meters. If the higher level was used instead, we already have seen that the ball will be hit further if it was hit from the higher level, and that extra distance traveled horizontally will be 10 meters. So here we have that particular increase of 10 meters. Finally, the question wants us to deduce whether an upper level at a height of 4.5 meters would be sufficient to produce this increase. You should ignore air resistance. Deduce type of questions means yes or no questions. So based on your calculation and working, you have to come up with a conclusion, yes or no, that the question is asking for. These types of questions are asked by the term deduce. So we have to find out if this height of 4.5 meters is enough to make this increase of 10 meters horizontal. So we have to find out yes or no. That's why it's deduce. All right, so let's make a sketch quickly. So first, let's sketch for for the lower level. Say this is our ball. Okay, it will travel a path like this to hit the ground. So this is the ground. All right, and okay, the horizontal distance traveled, let's say it's 92 meters. This distance is 92 meters, and this distance is also known as radius. Sometimes we take the translated out and here. So this is horizontal displacement of the lower level. All right, then okay, we have the higher level. Let's use a different color for the higher level. This is the ball at the higher level, and this is the level it is at, and this is 4.5 meters high from the ground. All right, and the projectile of this ball will look something like this, as they claim that this ball will land farther away. This ball will land farther away than the previous ball. All right. Okay. Then we have the velocities. The initial velocity was 33 meters per second. Same for both balls. So just we can just draw for one of the balls 33, and we also know the angle. So the angle here is 28 degrees, 20 horizontal. And okay, we have the angle, we have the resultant velocity. So always make sure to break down the components immediately because you'll need it anyway. It's also free marks. So the vertical component, we can call it UV. So UV will be equals to 33 sine 28. I'm going to assume you know how to break down the components using trigonometry, sine and cos, so I'm not going to repeat that here. Okay, similarly, we also have another component, the horizontal component, UH. So UH will be equals to 33 cos 28. Okay, we have our components split up, and then the golfer claims that if the ball is hit from the higher level, it will land farther away, and that extra distance traveled horizontally they claim to be 10 meters. So this distance is 10 meters, which basically means that the horizontal displacement or the range of the ball hit from the higher level in total is 102 meters. Okay, all right. And one last thing, for the ball that is hit from the higher level, when it again returns to the same height, it's still on the air. So at this point, vertical displacement of the ball is 0. It doesn't stop here. It goes further down by by 4.5 meters, which is the height of the level. So when it finally returns to the ground, the vertical displacement of the ball will be negative 4.5 meters, which basically it's going beyond 0. That's it. All right. So we have the technical details in front of us, and we just need to verify or justify that if this height of 4.5 meters is enough to give us this extra 10 meters or to give a range of 102 meters for the ball hit from the higher level. So basically we need to find out the horizontal displacement for the red ball here, the upper level ball, and see if it's 102 or something similar or not. All right, so we can now move on to the math and I'll just okay, I will just make up some space for the math and keep it here. All right. So there. So I would like to give you a top tip here. Whenever you want to find, the horizontal displacement, you always will need to find the time of flight first. T. You always need to find the time of flight first, and that you have to find using the vertical motion. And then once you got it, use the time of flight to find the horizontal displacement or range using the horizontal motion. So make sure to remember this workflow, as this is what we always use to get to the horizontal displacement starting from the time of flight. So here as well, we're gonna start by finding the time of flight, and since we have to use the vertical motion, we're gonna assume that upwards is positive, downwards is negative. Also take the upwards is negative, whatever you like. But this is how we most of us at least prefer doing. Okay, so since it's vertical motion, we have acceleration here, which is negative g or negative 9.81. We have the initial velocity, and the vertical component of initial velocity is 33 sine 28. And then we also know that once uh, the upper ball hits the ground, the vertical displacement SV for that will be negative 4.5, and we can find the time now. We have the required value SUAT. So we're going to use the kinematics equation here, which is S equals to U2 plus AT squared. Modifying it a little bit, we can write it as SV is equals to UV minus half GT squared. Because acceleration is negative g, we can just write minus half GT squared. And then I put down the values. SV is negative 4.5. UV is 33 sine 28. T minus half 9.81 T squared. Okay, we're going to find t, and you might have guessed it's a quadratic equation. So uh, don't hesitate to pull up your calculator. Just use the equation mode to find the value as quickly as possible. You don't need to show your use of quadratic formula here. Just go into equations, number 3, and then start putting the values. The value of a coefficient here is minus half times 9.8. So minus half times 9.8. Let's put down the raw values. Then b is 33 sine 28. All right, and then c is positive 4.5. If you uh, move the 4.5 to the right hand side, becomes positive. So positive 4.5 equals, and we have the time 3.426. 3.426. So time is 3.426. Quadratic, you should be getting another value, which is most likely to be negative. Yeah. So negative values are not accepted because time cannot be negative. So just reject this one. We got the time, and this is again, like I said before, time of flight. This is the time of flight, or the time that the projectile takes until it lands on the ground, the upper ball. Okay, and okay, I'd like to add one thing here again. This all calculations for the upper ball. Okay, the red one here. All right, so now we have the time of flight. We have got the time of flight. Now we can find the horizontal displacement here, the thing we want, and we want to see if it's actually 102 or not. Okay, so for this, since it's a horizontal motion, we don't need to use any SUVAT here, because there is no acceleration. So we're gonna just use the simple formula: v is equals to s over t, velocity equals to displacement over time, and displacement is equal to v times t. The v here is just uh, the horizontal component of initial velocity times the time of flight. Just to make things clear for you, I'm specifying everything here. All right, UH we know is 33 cos 28. So 33 cos 28, 28 times time of flight t, which is found at 3.426. Calculator, so it's like in normal mode. 33 cos 28 times 3.426. This should give us the horizontal displacement of the upper bow, which is 99.8 meters. Okay, so SH is equals to 99.8 meters, which is equivalent to 100 uh, to 3 significant figures. All right, so okay, now we can see that this is 100 meters, not 102. It is short of 2 meters, which means that the claim made by the golfer that the ball will land 10 meters further is not true. Okay, we're supposed to get 102, but we got 100. So the ball went further by only 8 meters instead of 10 meters, they were saying. Okay, so we got our deduce, and it's not true. So at the end, you just have to write the conclusion statement here that the height of 4.5 meters is not sufficient. Okay, that's fine. The height of 4.5 meters is not sufficient because 100 meters is less than 102 meters. Okay, this is the conclusion that we were looking to find out. Okay, so that was all for the first part of the question.